Okay, welcome to this final portion of this week. It is not a lesson so much as it is an example that I think helps explain the difference between series and parallel circuits better. So what we're going to look at here is a comparison of the power dissipated by R1 and R2 in the two circuits below. In other words, I have R1 and R2. I'm going to go ahead and tell you right now that R1 is greater than R2. So resistor 1 is greater than R2, than resistor 2. Which of these two resistors will dissipate the most power in these two circuits? So in order to answer this question, we need to look at our equation P equals IV, which is equal to I squared R, which is equal to V squared over R. Now, right now, this may clue you in to why this question is not easy. Well, if we're choosing to say that power is equal to I squared R, ooh, that is not a good two. Oh, I can do that. Hey, nice. Okay, so if I choose to say that power is equal to I squared times R, well, then I can say that the power dissipated by 1 is greater than the power dissipated by 2, right? Because it is dependent upon R proportionally. But if I say that the power is equal to V squared over R, well, now a larger resistance means a smaller power. So P1 is now less than P2. So this raises the question, which is true in this situation, or in these two situations? To answer this, I'm going to divide our page up. Okay, this will be our series, and this will be our parallel. Well, what do we know in a series circuit? We know that the current through 1 equals the current through 2, right? That's a given. I also know, as was said above, R1 is greater than R2, right? Therefore, I can say that I1, R1 is greater than I2, R2. All right, I'm sorry I'm squishing this down at the bottom. I promise I'll put the notes so they're a little clearer up online. Hopefully this is visible when you're on full screen. Therefore, we can say that V1 is greater than V2. This sort of answers the question about which equation we should look at when we address this question. Because if we're going to talk about how R affects the power, we need to only have R affect our power. We can't have the other variable affect it. Well, if V is different for the two, then in this equation, it means when I'm comparing R1 to R2, the potential difference across the two is also different. Okay? And so therefore, we need to choose to use I squared R for a series circuit. And so therefore, P1 is greater than P2. Now let's circle back to our series circuit. If I take a voltmeter here and measure V1, and I take a voltmeter here and measure V2, V equals IR. I is the same for the two of them. R1 is greater. So R1 times I is going to be bigger than R2 times I. And so this measurement is greater than this measurement, which is what we mathematically showed right here. Now, if we look at our parallel circuit, let's look at what's the same. We know that V1 equals V2, right? Again, we know that R1 is greater than R2. Okay. Well, from V1 equals V2, I can say that I1 R1, right, is equal to I2 R2. Well, if R1 is greater than R2, I1 needs to be less than I2, which means the current in the two is not the same. Well, if that's the case, the currents are different and the resistance is different. So using an equation that has both of them in it doesn't make much sense to determine the power. I'm going to use the one where at least one of those variables is constant, the voltage. And we remember in a parallel circuit, the potential difference is the same. And so I will choose to use V squared over R, right? And now P1 is less than P2. Okay, again, think about what this means. Well, if the potential difference is the same across the two, it's as if each resistor is connected directly to the battery, which means a smaller resistor will have a larger current. Power is equal to IV, Same V, larger current means larger power. Going to our actual demonstration circuits. I wonder if I can put that right there. Let me bring my circuit over to here. Now we're going to just look at bulbs A and B. We're going to go ahead and ignore C because we're only dealing with 2 bulbs. Let me create my series circuit here. I have it coming out through the bulb, down through the wire, over to here, up through bulb B, through the filament to here, down into the negative component or the low potential. So this is my series circuit. Look at the brightness, right? They're both equally as bright because now I have a situation where both resistors are the same. They have to share that potential difference because it's a series circuit, and so they're dimmer. If I want to make this a parallel circuit, what I'm going to do is I'm going to take this guy here, I'm going to put it there. That's not it yet. I still need to do one more thing. I need to connect B into this circuit, like that. Okay, well, hopefully you can see that this is quite a bit bigger. That's because A and B both have the same potential difference over them. If this were an actual battery, you may be asking the question, how can the battery just give whatever's asked of it, right? How can the battery just give whatever current the system of the circuit requires? Well, the answer to that is the battery is set to give a certain amount of potential difference, right? It has a maximum current, but usually whatever we're going to attach that battery will be lower than the maximum current. So there's a potential difference and a current is drawn from it. If this were a battery and we compared the parallel arrangement to the series arrangement, what we would observe over time is that the series setup actually lasts longer. In other words, the battery dies over a longer period of time than the parallel arrangement. So the bulbs in parallel will kill the battery faster than the bulbs in series. Okay, so again, that is it. I hope that kind of helped tie things together a little bit, and this wasn't too much for this week. I hope you're all doing well, and I will see you soon at both group work and at the lesson recap. Please watch the videos before the recap. And if you do, you will know the keyword, which is Pizza Claus.